Dr. Goodarzi, are you ready to present? Oh, there you are. Hi, Erin.
Hi.
Give it just a minute for everybody to switch over into the right session. So we have a stop at 11:35 to get questions answered, and I'm sure you're going to have quite a few. So.
Okay. Should be fine for 35 minutes. Yeah.
And I'll give you, if you'd like, a 5 or a 1 minute warning, either way.
1 minute is fine. I've got a timer here, so.
Excellent. Okay, I think we've got quite a few people that have switched over. So I am here at ARS, we're very lucky to have 3 keynote speakers for this special year. And our third keynote is Dr. Erin Goodarzi. Dr. Goodarzi is an assistant professor at the University of Calgary's Arnie Charbonneau, can't speak French very well, Cancer Institute at the Cummings School of Medicine, and currently holds the title of Canada Research Chair for Radiation Exposure Disease. He is a globally recognized researcher in understanding how radiation impacts our DNA to cause genetic damage and ultimately cancer. He currently leads the Evict Radon campaign to test homes across Canada for radon gas. His research work has led to an explosion of radon awareness in Alberta and Canada-wide. He has done some amazing work with Citizen Science Project of Canada. Without further ado, let's hear Dr. Goodarzi's topic, harnessing the power of citizen science to defeat the 21st century radon exposure. Dr. Goodarzi, welcome.
Hi, thank you so much. So thank you for that very kind introduction and for the invitation to speak to you all today. So yeah, I'm going to tell you in the next sort of just over half an hour our experience in Canada about using citizen science to address the worsening radon problem. So just by way of getting the stuff out of the way, I have no conflicts. And within Evict Radon, we're very careful that no member of our team, which are primarily comprised of university professors and researchers, profits either directly or indirectly from radon testing or mitigation, right? Which is really important for building trust with our base within the public space. So I'm based here. This is the Charbonneau Cancer Institute in the west of Canada, just on the eastern side of the Rocky Mountains, near Banff, if any of you have visited our areas in the before times, before the pandemic. And many of you will be chiming in from places, not just all across North America, but across the world. And it's important, I think, to recognize that cancer is a geographically varied problem, and cancer prevalence differs globally. Here in North America, lung cancer is the most prevalent type of lung cancer, but it's different everywhere else in the world. And based upon this map, you can see colorectal cancer, breast cancer, and other types of cancer in different organs are the most prevalent in other regions. And so why is lung cancer the most prevalent here in North America? And that's a problem, I think, that we will get to as I move through this talk. One thing we do know is we have a massive lung cancer crisis. Compared to the other major types of cancer, for example, breast, prostate, blood, brain, etc. Lung cancer has a huge number of cases. These are Canadian cancer statistics, by the way. They'll add a 0. That's probably what you have in America. And by the numbers, lung cancer is the most lethal, the highest lethality type of lung cancer, just due to the nature of it being diagnosed so late because it doesn't present with symptoms soon enough. Screening is not widely available yet, and it's really difficult to treat. You can survive without a prostate, without a breast, but you cannot survive without your lungs. And so how can we do something about this? Because it affects all demographics. And so this is cases and deaths you can see there. By age, it is not just a disease of the very elderly. And in fact, if you look in Canada, and the numbers are also similar in the United States and Europe, young people, and by that I mean under the age of 60, including a whole bunch of people in the 15 to 49 bracket. Indeed, in Canada, we had about 600 people last year as young as 15 years of age with lung cancer. It affects all demographics, particularly the lung. And of course, I don't need to tell this audience, radon is the second leading cause of that. Now, this is all about our DNA. which gets broken by the radiation that radon gas emits. And, you know, the nice normal DNA that we'll start life out with, this being a nice normal, in this case, girl cell, 2 little X chromosomes you can see there in green, that we start off, you know, half from mom, half from dad. That is subject to damage. These are the top 9 sources of environmental cancer out there, including things like alcohol, tobacco, too much sunlight. And if we take that away, these are the ones that cause lung cancer. So air pollution, tobacco, heavy metals, and asbestos. And radon is right there as one of the leading cause of that. Radon, of course, is radioactive. And I'm a radiation biologist. It's something that I've been looking at for 20 years now, being in the lab. And we know that radon is the #1 way, the single largest source of lifetime radiation exposure. Unlike that medical radiation, radon's a little different because radon is a particle radiation versus a photon radiation. What do I mean by that? I mean, if you take an X-ray or a gamma ray as part of medical radiation, that goes through you very quickly. It doesn't actually do all that much damage. You know, get your dental X-ray. It's pretty safe, very safe, in fact. Versus particle radiation, which bulldozes through the DNA of our cells, creating absolute genetic havoc. These are very different creatures, and from a radiation perspective, much, much more serious to study. To illustrate that for you a little further, if we cartoonize just 5 little pieces of DNA here in different colors and look at, say, what happens when we throw an X-ray through them, you get widely spaced DNA damage. Very straightforward to actually repair that. But if you compare that to what happens if you throw an alpha particle from radon through that, you get an absolute shredding of the DNA. Our fundamental ability of our cells to damage DNA, to repair damaged DNA, is just not good at doing that. And because there's so many different types of damage and so densely clustered, our cells get it wrong, driving them from the normal to the cancer, which is this panel B I'm showing here, where you're missing whole chromosomes, you have multiple copies of others and monsters at the bottom there you can't even recognize. That drives them towards cancer. This is not a theory, this is fact, this has been observed. This is actually in the Sources and Effects of Ionizing Radiation, a publication from the United Nations, looking at the relative excess incidence of cancer on the y-axis there, per dose of photons, meaning an X-ray or a gamma ray, versus particles, which would be the type of radiation emitted by radon. You can see the steepness of that curve is unbelievably high. And when I speak to members of the general public about it and contrast the two, a photon is like me shooting a single arrow at a building, not particularly all that much damage to that building, contrasted to particle radiation, which would be a 580 square meter carpet bombing of the building. As far as your cells are concerned, particle radiation is completely and utterly different, extremely cancer causing. And indeed, we see that in the relative excess incidence of cancer. In the EVICT radon study, we've been able to actually calculate the actual lung radiation dose for thousands and thousands of our citizen science participants. By taking the radon level they're exposed to, combined with the years they're living in the property, we're getting better and better doing this all the time, converting that to their millisievert, which is actually the absorbed dose of radiation to the lung per year. And using ICRP formulas. And so we can categorize our participants into low exposure for short duration, high exposure for known long duration, and everything else in between. This is the formula. You can go to the ICRP website for their latest formulas on how to convert that. You have to know the exposure per year in order to do that in the given radon environment. And this really only should be based on long-term radon data. But by doing that, we can see we have plenty of people, thousands and thousands of people just in our sample cohort who are receiving something in excess of 180 millisieverts a year on average, with some heading way north of that. Indeed, about 1 in 6 homes in our part of Canada are receiving 0.2 to 10 millisieverts a week. Now, to put that into context, the Canadian, and indeed I think in other countries as well, maximum tolerated dose over 5 years for an atomic energy worker is less than 5 millisieverts. And we have people in our house getting 10 millisieverts and more a week. This is an experiment that was done back in the 20th century using rats, exposing them to radon gas at multiple levels. And look at who got lung cancer. Surprisingly, actually, the higher the dose per week, the less cancers you got. That's simply because dead cells don't become cancer, but the lower the doses, at 12 millisieverts a week, more than 75% of the rats got lung cancer at a cumulative dose of 4,000. Now we're seeing in the field in Canada doses at that range, 10.7 millisieverts a week. It's unsurprising that we have an enormous burden of lung cancer as a result. Again, this is data derived from this reference, which you. So we have a lung cancer crisis and a radon-induced lung cancer crisis. And what we're about is trying to solve that problem. So understanding how radon exposure happens, it's not just purely driven by the geologic environment, behavior and on our built environment matter strongly, and then working out ways to engineer that out and prevent it. More so, we're also interested in radon-induced cancer susceptibility. Not everybody is equal in terms of this. It varies based on your age, your genetics, your ethnicity. But we don't fully understand who is who at this point. It's really important to understand that, because by identifying the vulnerable, you can actually protect them better. And then better biomarkers. Right now, there isn't a blood test for long-term lifetime radon exposure. This precludes referring people-based screening programs. Just doing a radon test in your house is never going to be good enough for referral to those programs. We need a blood biomarker for this. And indeed, we're working on it. I'll come back to that later. So, Confederation of Scholars in Canada, we're actually working on all three of these problems from a variety of angles, and we're using citizen science to actually do that. And so, this is a comic from Fritz Alfacht there. He's actually a Danish scientist, or artist, I should say. Showing that, you know, when a scientist needs help, there's a lot of people in the general public who want to reach out and want to help out. And so this is what we've done. You know, citizen science most commonly has been used in the fields of astronomy and botany, zoology, you know, mapping butterfly migrations and insects, more recently in computing and solving problems for that. But what if we adapted it for cancer prevention? And indeed, that's what Evict Radon is all about. You can read more about us at our website, which you can see the URL there. But I'm going to tell you about our story in the next little while. So it involves a series of universities getting together with professors like myself. I'm based at the University of Calgary. But you can see all across Canada, in Saskatchewan, British Columbia, Quebec, and the Atlantic provinces, we've come together. And we're from all sorts of different disciplines. I'm a biologist. But we have geologists, physicists, population health architects, everyone else in between involved in the team to build this out. And this really has involved the galvanization of Canadians from across the nation in order to make this possible, because we know what we have to do. We need to understand not just what high quality radon exposure looks like, but based on long-term testing throughout the nation, but to completely couple that to a detailed understanding of behavior, geology, the built environment, and health and medicine. So this is a national study to understand with the goal of engineering out radon. And in 4 years, we have successfully radon tested 52,000 people in 20,000 homes. We've published 3 studies so far. There's 6 more nearing completion. We've contributed to an award-winning real estate education course now in my home province of Alberta. Every single real estate agent has to actually pass a test, a course on radon, and is a really strong advocacy group. We've been able to lobby and get new laws passed on radon awareness and testing, which by any metric is pretty good, considering we've never paid for a single radon test, because this is about citizen scientists coming together. They purchase their nonprofit radon kit, but agree and consent to donate the data to us because it's about Canadians coming together. So I'm going to take you through a variety of examples on how we did this. The first is define a very clear call to action. Evict Radon is the title that our brilliant communications director, Weston Jakes, came up with as our call to action. It's very simple to understand. Explain how everybody can help, create a very simple process for them to follow, get the message out as widely as possible. Predominantly, we're doing that through digital means, which means the pandemic, although it is complicated how we do business, it has not stopped business in any way, shape, or form. Supporting the participants as much as we possibly can, building trust with very interesting science, and ensuring the participants, all those citizen scientists, those 52,000 people and counting, can see the impact. So this is just the homepage. You know, we have a cycling series of messages at the top there. What is radon? Why should you care? Tell people why they should care. Don't assume that they're going to know. Tell them why they should care. They may disagree with you, but at least if you tell them why that you think they should care, they may agree. And then tell them what they should do about it that helps further the specific endeavor that you're trying to provide them with strong peer-reviewed information. We have a variety of information available on our website, all of which is backed up by peer-reviewed citations, but we digest that information and make it accessible, at least at the grade 8 sort of level of language and understanding. Being Canadian, we're in both English and French, and are, you know, in the future, if we have capacity, explore other languages as well. If you click on one of those, it pulls up a variety of facts. You can see there an example of our page on radon exposure in children. Make the journey as straightforward as possible. And so, as I say, we do a lot of public relations, press, digital media outreach. People visit our website, read about the study, and then possibly, you know, decide to consent into it. It is about informed consent purchase. They get their kit shipped to them. They place it, register it, complete our home metrics survey. They're all consented to be contacted for other radon opportunities. They test their house for 90 or more days. Often our participants do 6 months to a year, and return the kit, get their results. Part of this process involves understanding how people are hearing about the project and deciding to act. And what we know, based upon a sample of 2,500 of our participants, is that most of this is through traditional news media, print, media, radio, television. The rest of it is a combination of word of mouth, social media, and others you can see there. So of course that informs how we should actually go about recruiting people, because we know, again, that people need to hear about this between 3 to 5 times minimum before they'll actually go on and get a test, right? So you can't just tell people about it once. That maybe works in 1/5 of cases. You need to keep telling people most 2 to some people very resistant up to 10 times before they'll do anything. So we spend a great deal of time, and thankfully in the media in Canada, journalists have been very supportive of what we do. In fact, I was just doing a TV interview just a few minutes ago. It's Radon Awareness Month here in Canada. And so make yourself available for doing that when asked to do it. Very important to do this and build trust through the best research ethics practice. And so every single thing we do, every aspect of our process, every image we show is approved by our research ethics board here in Alberta with the study ethics ID there. And all of our participants are able to download the full research ethics and consent into that before they even get their link. In fact, it's a condition of the study that they have to consent into the process in order to receive the link to even purchase the nonprofit radon kits. We do this whole process under the with the cooperation and the assistance of CNRPP, Canadian National Radon Proficiency Program professionals, who oversee our quality control, which of course encompass things like free duplicates. 5% of all participants will find an extra device in their kits that they're supposed to place right next to it. And that's how we can assess that our precision and our accuracy through blanks and spikes are exactly where they need to be at 96% or 99% in terms of precision and accuracy. If you're ever going to go on and publish this data, these are essential things that you have to have in order to be believed by the international scientific community. You must support your participants, provide information, clear pictorial information. Like our instructions, for example, are closer to IKEA instructions. You don't even need to read, really. You just follow the pictures in order to place the test. But if you need more information, you can click on the website and there's much more detailed instructions. You have to understand that everyone knows what their participation can achieve. And this really helps propagate involvement in the study and that word of mouth, right? And so on our website, again, we tell people exactly what we're able to do with their radon results, which include things like understanding why certain properties have higher or lower radon, figuring out new ways to engineer it out, consumer protection, early detection, and things like that. You have to ask engaging questions. And my call out is that, for goodness sake, don't just map radon. I know it's very tempting just to map radon, but that's not sufficient anymore to address the massive lung cancer crisis. We've been understanding the intimate relationship between radon exposure and our built environment in Canada. And we know that newer properties have far, far higher radon than even properties from 40 years ago. We've been actually working with folks like Trygve at Radon and others to actually compare this across countries. Here, for example, I'm showing you one figure where we know specific build types in our region. So this is the west of Canada. The bungalow is king as far as high radon is concerned in our part of the world. We have metrics on like 50 detailed metrics, and we're able to combine those through multivariate analysis in order to understand and predict what type of property is going to have high and what's going to have low radon. We know that Canadian radon exposure is getting worse, and in fact a lot worse. And by contrasting that to other countries like Sweden, and this is part of our work we're doing with Radon and Trygve, we can see how in Sweden they have been very successful at engineering out the innate risk of high radon. That's in blue there. And if you compare a house built in the mid-20th century to one built today in Sweden, they've very successfully engineered out their innate risk. Where in Canada, the exact opposite trend has happened. And since the start of the 21st century, our radon risks have skyrocketed. In fact, are now 600% higher innate risk compared to Sweden. We also know, based upon the age of the folks in newer houses, younger Canadians tend to be in new houses, which is their starter home. It's that first little small condo. Those have amongst the highest radon imaginable, which is the exact worst scenario that you can imagine, because we know younger people are more sensitive. Not only are younger Canadians in those houses, but that's where they're having their kids in the youngest years of their family. We also look at modifiers like behavior. We look at a variety of these, but radon we know can be altered by very trivial lifestyle things. You can have two people in the same, it's two families in the same house. One family sells the house to another. They never had a radon problem. The next family moves in. They don't change anything about the house, but they have a radon problem, and that's down to behavior. Things, for example, like window opening. One family never had the windows open. The other would never dream of having them closed. More likely you are to open a window. Statistically speaking, across a large population of thousands of people, or houses, I should say, you're going to have lower radon. We also look at responses. Again, this is about protecting our participants and supporting them. And so, what is their immediate emotional reaction when they first receive their radon result? And of course, it breaks down. 65% are relieved. That's because they had a low radon outcome. But if we break this down by actually the result, you can see, as you might imagine, if they're over 1,000 becquerels per cubic meter of air, you got a lot of very negative emotions swirling there: anxiety, fear, anger, disgust, dark side of the force going on there. And so it's really important to understand who's who, because not everybody is the same. Some people experience very negative emotions, even at what we would consider lower end radon. And this is about supporting them through that process. We also ask questions and figure out who's resistant to the message. So we asked the same question two different ways. So we asked, I will remain healthy even though I'm exposed to radon due to my general good health and physical resilience. Do you agree or disagree? But we flipped it. We had, I'm worried about radon's ability to cause serious illness in me in the future. Agree or disagree? And there were folks who completely disagreed with the fact that they will remain healthy even though they're exposed, agreed with that fact, and disagreed with the fact that radon might cause illness in them. So who are these people who are extremely resilient or resistant to radon health awareness messaging? And it's a significant number of people, up to a fourth of people are resistant to this message. But by understanding them and tweaking your message as a function of that knowledge, you can actually encourage more people to radon test. It's not just that people think they're invincible. The joke is, all teenagers think they're never going to fall prone to any sort of disease, and some people never grow up. This is actually about human optimism bias. This cartoon is very similar. You've seen it widely in the media all over the place. And a lot of people, no matter what you tell them, will think that it's not going to affect them. So we might have all seen this cartoon a lot, especially on social media. Have you seen the rest of the cartoon? It's actually from the artist K.C. Green on the Gun Show comic strip. And as you can see there, fold down, it gets actually pretty graphic. But given the radiation effects on the lungs, that's not particularly surprising in that place. So we do a lot of effort in getting out into the communities as well, not so much this year, but in previous, this is me photographed with the mayor of 1.3 million people in my local town of Calgary, giving him a radon test, which he went on to do and advocated out to, again, what those 1.3 million that he did it, so everyone else should too. Regular news stories of a variety of different topics make important, and then target them to your regions of interest. And keep it fresh, keep people engaged, keep them on your newsletter. They can unsubscribe from that, and a small percentage does, but it keeps most people interested because your citizen scientists want you to keep in touch with them regularly. Most importantly, you have to ensure the research is peer-reviewed and then published in an open access journal, and then release and publicize it professionally. This is one of our more recent papers that came out late last year in Scientific Reports in Nature Publishing Journal. And of course, we promoted that, and national news did many, many stories on it. And then that gets more people signed up and interested in the study, which begets more papers, and around you go. We have 6 more in the pipeline right now. There is impact from this, convincing participants to mitigate, and that will be of interest to many of the people chiming in here who may be in the radon mitigation industry. Of the % of our participants who identify a need to mitigate their home, what we know is that 35% of those who needed to mitigate already have within 1 or 2 years of doing so, and another 53% indicate their intention to mitigate, and either they're saving up to it or just trying to find time to do that. And that correlates right now to 1,300 mitigations done, 2,000 mitigations pending all across Canada, with business acquired by a whole slew of radon mitigation companies. We don't sponsor or endorse any specific company, but in Canada, there's a resource where people can go and just enter their postal code, zip code for Americans, and then it spits out an alphabetic list of mitigators near them, and they make a choice. As I say, asking engaging questions is really, really important as part of doing this. One thing we're doing right now, and we launched actually on Tuesday, was a large study focusing on working from home. This was something that we knew varied by job, your occupation. Certainly some jobs won't never let you work from home. For example, nursing, you can't really do too much nursing or be a medical practitioner working from home. It depends on your age. As well, a lot of jobs for young people, if you're bussing tables, that's not something you can do from home. But we knew, based upon data, this is actually data from the Seattle metro area, that working from home was increasing anyway. And actually there was an increase across many United States cities and Canadian cities as well, of more than 50% in the past decade, from 2007 to well, of course, we know that that is absolutely skyrocketed this year. Don't need to tell you. And we actually launched a giant COVID-related study. This is just our preliminary data, looking at individuals and how their exposure to radon in their residential environments changed. And our preliminary data indicates a 35% increase in radon exposure in 2020 versus the before times. This is only based on 24 people. We launched the study on Tuesday. We already have 4,000 data points, which we'll be analyzing very soon, with another 12,000 houses pending on that one. So this is going to be one of the largest radon-related COVID studies, I think, that will be out there, with individualized level data as a function of their job, their retirement status, their educational status, all those metrics, their age, and in what type of house they're in. What are our essential next steps? And here's where I'm going to wrap up. So Vic Radon is based purely in Canada, and we're doing a variety of things right now, but we really do need to level up. We're at a good level, but we need to get to our next level to make a real difference and to address the lung cancer crisis. So of course, the first that we're very interested in, which our architecture teams, our building science teams, is understanding how we can engineer out radon from the Canadian built environment. I showed you this graph before of Canada versus Sweden. We would like to become where the Swedish are in a much shorter time frame than 50 years and go from where we are now down to where they are now. And this is very urgent, which of course involves engaging with folks who can have control over the build codes. But first, understanding what we have to do, because we don't know what we have to do. And similarly, through our analysis so far, the Swedish don't know exactly what they did in order to get there. It's not anything obvious in either build code. It's not just as simple as energy efficiency or HRVs or anything like that. This is actually quite complicated. We're using machine learning to get there. So stay tuned for those outcomes in the next year or so. We also need to discover novel biomarkers, again, that blood tests for radon exposure across a lifetime, because until we have that, we are not going to be able to refer people to early lung cancer screening programs. The technology exists to screen people for lung cancer. Low-dose CT scanning is what it is, but it will not be available to people simply on the basis of a short-term radon test. And even in one property, even with, say, a 90-day test from one part of your life, you really do need lifetime-based data in order to do that. We're working on that right now through our study, because this is so important for early diagnosis. What is the bodily footprint of that process? And then radon-induced cancer susceptibility, figuring out who are the vulnerable amongst us. We know that 1 in 30 people who receive radiation therapy for cancer over-respond quite spectacularly, ranging from a little rash to they drop dead. And so radiation sensitivity is a thing within the general population. And of course, using that knowledge, we want to be able to figure that out. My lab has in fact invented new technology for looking at chronic, repetitive, low-dose alpha particles to replicate of what we see in houses all across the world, which is very difficult to do previous to this. And we recently received a $1 million grant in order to pursue that, in order to discover who's vulnerable and to combine that with our previous work looking for the radon-induced lung cancer gene signature, so that we don't have to guess whose cancer was due to radon. We know just by gene sequencing the tumor. We can do that right now for tobacco. We don't need to know anything about someone's tobacco history in order to tell them that tumor was due to tobacco, because the evidence is in the gene signature. We will be able to do that for radon, give us a few years. And so, yes, we're launching a new mega study on this. This is now funded. It's actually started several months ago in collaboration with a variety of organizations. But overall, we're working with CanPath, the Canadian Partnership for Tomorrow's Health. This is a large longitudinal health study with 1 in every 100 Canadian citizens of the entire nation signed up. And what we have is data, access to their medical records. We have their DNA. We have their blood specimens, tissue specimens, like toenails, things like that, going back at more than 15 years in some cases. And we are radon testing this entire cohort. We're starting in the east of Canada with the Quebec and the Atlantic provinces. That's been underway for this past season. We're progressing now to do this throughout Alberta. And with this power, radon, high quality radon exposure data, long-term data from every home they've been in, every workplace they've been in, coupled with every single biomedical specimen you would want, we're going to be able to achieve our goals that I just described about the biomarker, the radon-induced lung cancer gene signature, but also understanding what we need to do to engineer this out. This has been funded by the Canadian Institutes of Health Research, $1 billion grant over the next 5 years. This is due to the amazing power of citizen scientists in Canada who are definitely the friend of science and helping promote this. We would not be able to do that without the Evict Radon cohort and the CanPath cohort for doing that. And so to remind you, if you want to do this locally, feel free to reach out to us, but define a clear call to action, explain how everyone can help, create a very simple process, get the message out widely, support your participants, build trust with interesting science. You need credible scientists in public institutions in order to do that. Ensure the participants can see the impact. If you want to learn more about our study, evictradon.org is our website. I actually wrote a paper on this, published it last year on using citizen science and getting research ethics approval for that. It wasn't a trivial process. I co-wrote this with actually the chairs of our research ethics board after, of course, we received approval. But if you want to learn more about how you do that and some of the considerations, because your local ethics board may not know about this, because ours certainly didn't, and we had to work very closely together in order to make it happen. You can look at any of the other Evict Radon publications, free downloads on our website. If you go here at our publications page, And I will end by just again flagging our most recent study, which was a Nature Publishing Group study in Scientific Reports. Again, you can find that on our publications page. Thank, of course, all my many colleagues and professors at the other universities across Canada. You can see them here in our funding, which comes from a combination of these agencies, and happy to take questions.
That was amazing, Dr. Goodarzi. Thank you. We have quite a few questions, so I'm going to turn it over to Jane and Amy with questions that came in from both chats.
Okay, let's see. First question that came in, are some people more likely to get lung cancer from radon due to hereditary reasons, or does that matter?
Yes, it absolutely does. And yes, the answer, they are. We know there was a study published a few years ago based upon thousands and thousands of gene sequencing studies. There are very prevalent changes in our genetics that basically come down to us through our family lineage. These are called single nucleotide polymorphisms, or SNPs, prevalent in 1% of the population. And they correlate strongly with a likelihood of lung cancer. There are people out there who are more likely to get lung cancer as a consequence of radon exposure versus others. And similarly, there will be some people amongst us who are resistant to it. So not only are they vulnerable, but there's also a few superheroes out there. But we don't know quite how to figure out who's who right now. And that's a big part of what we're working on in the mega study right now and received funding to do.
Next question from Catherine Pruitt. Love this project. What do you know about the diversity of the participating citizens? Are you getting?
Yeah, we have the full demographics. So pretty diverse as a function of our local demographics. One thing that we need to do better on is recruit younger Canadians into it. We know we're missing Gen Z. We're not too bad with millennials, but we want to do better there. And then Gen X and onwards, no problem. It's a little bit biased towards older demographics, but we actually are engaging in a whole project. We received funding Health Canada this year to tweak some of how we reach out to younger demographics. That's the big place we need to do better. In terms of education, they tend, of course, in any public health study like this, a little bit more educated than the norm. Incomes, again, not super different to the norm. Equal number of renters. What we do know is we tend to have more people who are married and who have families in our study, but that's also a function of age, where we're missing some of the younger folks out there. So we've identified all of the demographics we're not doing as well with, and we'll do better for that. From an ethnic perspective, we also are doing pretty well there too.
Right. Next question from Ryan Fox. What is about recent Canadian construction that is leading to seemingly ever-increasing levels of indoor radon?
It's a great question. If I knew that, I would have already published the paper. So we're working on it. We have a variety of leads, but we're not 100% sure at this point. The biggest correlation that we have is, of course, year of construction. But that also correlates with a few things like the surface area of the building footprint. So newer houses tend to have larger square footage. If you double the footprint of a building on the ground, that's that much more surface area upon which to draw radon. So that's just one factor. It's not purely about HRVs. The Swedish have a lot of heat recovery ventilation, very energy efficient homes, and they don't have a radon problem. In Canada, though, the way ours have been installed, if you have an HRV unit, you're actually more likely to have higher radon, but I don't think it's actually causative. I think that's just a correlation thing. In the cancer world, we talk about a driver mutation and a passenger mutation. So some effects may just be along for the ride, and you see them in the higher radon ones, but they're not actually causative. So what we're doing right now is applying like the same approaches that we'd use to figure out what's causing a cancer, but actually what's actually causing high radon in new houses. And so if you actually look at our 2019 study from the website, you'll see where we got to so far. That itself would be an hour presentation, so I won't elaborate on that, but I'll refer you to that paper to see where we're at now. But one of the 6 studies we've got coming out soon will help get us even further there.
This next is from Amanda Hong. Dr. Goodarzi, thanks for this fantastic presentation. Do you do anything to support your citizen scientists with mitigation, especially those who are very concerned with test results that show higher radon levels in their homes? And then she says, we often run into a philosophy of ignorance is bliss with groups that don't have budgets to support mitigation funding.
We absolutely see that as a concern for many folks who land on our website and social media pages, but recognize then that they're not able to do anything about it, and they don't want to know. And so we're talking about subsidizing radon mitigation programs. Well, you know, we can't even pay for people's radon tests, so we don't actually have the funding to do that. But in Canada, there are a few programs. The national awareness program is called Take Action on Radon. They actually do run sort of more like raffles for folks who can get, they can win free mitigation. This is not going to address the systemic barriers that we see for lower socioeconomic statuses. So we're actually working together with a variety of public agencies in order to increase that. One good thing is that we do have locally here is that if you rent your house, which is you know, more likely to be your situation if you are in a lower socioeconomic status and you do a radon test, your landlord is actually legally obliged to mitigate that rental property for you. So that's one good piece of news that we have locally, but that's not universal in Canada. And so this is, again, part of the lobbying efforts that we are doing. And as politicians recognize the scale and the seriousness of the radon problem and the burden in economic terms on the healthcare system, they actually become much more willing to do something about it. So we're sort of moving the chess pieces on the board with good science to a position where it's kind of checkmate, where public health authorities actually can't say no to some of this stuff because there's just too much of an economic argument in favor of subsidized mitigation, especially for those who can't otherwise afford it.
Okay, next question is from Burkhart. Your slides showing DNA damage, which I first saw in Vancouver some years ago, are very compelling. Assuming proper credit is given, may I use those slides in presentations to the general public?
Yeah, just email me and I'll send you versions that you can use in public. No problem. Yeah.
Okay. This is from Gary Burke. Thank you, Goodarzi, for your great work. Who or what entities are spearheading research in the built environment as far as engineering out things such as envelope research, ventilation, mitigation techniques, etc.?
Us. Yeah, so the Associate Dean Research of the School of Architecture at University of Calgary is actually on the board of Evict Radon, one of my key colleagues. So through Dr. Taron, who's an architect by trade. He's actually American by birth. He's from Los Angeles. He's been a big proponent of us trying to understand this. And then, of course, with his contacts through the building trades, home inspection and certification, and all of that, we're pushing there to make real change. And so it's again about speaking their language. You know, because every field and every industry has a little bit of a different language, but we're out there doing that. I gave a talk to a large group of folks in the sheet metal industry. Why sheet metal, you ask? Well, they're the ones who actually install furnaces in this part of the world. And it's a very important stakeholder agency to do. So the answer is us in Canada.
Great. That's the end of the questions that are in the various input opportunities we have. A number of compliments here from all around our industry. Thank you.
Mm-hmm. If you have more questions, again, you can email us at info@evictradon.org, and the team will forward those up to me for responses. And thanks everyone for attending.
Thank you, Dr. Goodarzi. That was fantastic. We've gotten quite a few responses, and I think it was a very highly attended session. So thank you for your time and your information.
Thanks so much for having me.
Have a great day. So next up, we are getting ready to go to our next session. It's our last morning session and the last of this week's 3-part series, the Rocky Radon Horror Show. This time each day we've been presenting with Peter Hendrick, our Executive Vice President for Government Affairs. So what's up with this is an art series of, what's up with this? An art series of video shorts on real radon case studies from the main street, describing what can go wrong when untrained, uncertified contractors and a few others that are certified ignore national standards and do substandard work. The goal is to compile a series of examples that informs policymakers on the value of radon standards and properly training and certification. This is a recorded video, but Peter is engaging live in the chat feature. So reach out, laugh, and share your horror stories. So if everybody ends out of here, goes back to the agenda and clicks on that video, you'll be able to view that video and chat with Peter Hendrick. So I'm signing off. I'm done with my duties for this year. So thank you, everybody, and have a great rest of the symposium.
Thank you so much, Crystal. We really appreciate it. And we're back after lunch at 1:30 live. So everyone go on. We will go ahead and turn off this session and head over to Peter Hendrick's session. Have a great morning.